So today's repair is going to be on a circuit board for an AC unit. This particular circuit board is used for heat pumps, AC units with heat pumps. My unit kept freezing over, so the cause of it I was able to find down at the circuit board level on the AC unit. What was happening was it kept freezing over on the outside of the house. It wasn't triggering it to the circuit board to turn off the system, so it just constantly kept running and running, so it caused kind of like a snowball ice effect on the outside AC unit, which isn't good. So with my electronic skills, I'm going to try to fix this again with past projects I've done. So I'm going to show you right here. This is the circuit board that I took out, and right there is the capacitor. You can see that the capacitor is blown. That's a dead giveaway that there's a problem here. And it's usually an easy fix once you find out what the problem is. However, when you flip this thing over, you end up seeing on the other side that there are trace lines on the board that have been fried from the capacitor blowing. So we got a board fried here, so the trace lines aren't there anymore, which I'll have to make a repair there and a repair right here as well. And there's a couple burnt ones right here too. This is actually an easy, a lot of people will throw this stuff away. This is like a $150 board brand new, and that's just the board, that's not the cost of the labor, technician coming out, and a lot of times they'll end up just selling you a brand new unit. So instead of doing that, I'm like, well, okay, let's just do a repair on it. There are like rollers, like kind of look like this pin out there with metallic materials in them that you can roll down across to reconnect these. But in an instance like this, I don't think that's very useful. So what I will end up doing is just cutting a little bit of copper wiring and kind of make a trace here and just resolder and make my own trace from a copper wire. And then what I'll end up doing is sealing the back of this with a material, so it's and you really don't even have to do that as long as it's not touching something else, or you can put some flux over it to help weather it a little more. And we'll see what ends up happening once I repair that, and I'll start making the video. See where it goes. Okay, so a few things we're going to need first to start this project is we're going to need some solder and solder sucker, so we can suck off the solder off of the board here to remove the components that are bad, and a solder gun and something to clean off the solder gun with, such as something like this, so we can prep it. So what I'll do is I'll just take my solder gun here and I'll clean it first clean it off in here. Then what I'll do is I'll take a little bit of solder and prep the tip of my solder gun. So there's a tip there, and I'm just going to prep it. So the smoke you're seeing is that flux. This particular solder has flux in the center core, and the flux is what's going to help it, the solder quickly bond to the board and bond to whatever components you're putting on or taking off, for that matter. So this is the bad capacitor right here. That's the part I want to remove. So I'm going to flip it over here and locate where that capacitor is. So it looks like the connection points for this particular one are this point here and this point right here. So you can see this point here in this point right here. So I'm going to heat it up and use my solder sucker gun here. That's what it sounds like. Prep this again, put a little more solder on the tip. I'm going to heat it up and remove that solder. Takes a few times usually. Heat it up again on the other side. Suck it out. I usually do it about twice. This one looks like it still has a little on it. Okay, so that looks like that's removed there. Set my solder gun down. Alright, so I'm going to flip it back over, and it should be loose enough for me to remove. It's probably a little warm from heating it up, but there it is. So that's the capacitor. What I'm going to do is try to find another capacitor, ideally the exact type of capacitor, and replace it. So I noticed on the other side of the board though that when the capacitor did blow, that it affected the trace lines going over to a few other components on the board here, like right here. So I'm going to clean this all up as well and put the copper lines in there I was talking about and see what we're going to get. So I'm going to pause this here. I was able to find the capacitor I needed to replace, and what I'm going to do is put in the new capacitor here. You got to make sure you place the capacitor in the right direction. So the black labeling here on the side of the strip, that's going to be your negative side, and the other side is going to be your positive. And on the way the board is laid out, right here is going to be the negative end right here, and this would be the positive hole right here. And we're just simply going to push them down in, flip our board over, and what I do is I just kind of bend it a little so it's kind of holds it as I go to make the solder point I need. And I once again prep my solder gun. I'm going to clean off the tip and prep it again with a little bit of solder on the tip. It kind of cleans it. You want to have a good clean tip. And the trick to soldering is, number one, prep that tip. Number two, prep the tip. Number two, you're going to quickly just kind of warm up the area. It doesn't take long at all. Just kind of warm it right up at that area there, and you tap it. Just a quick little, that's it. Just like that. And same thing over here. We just heat it up first, and we apply our solder. So our solder is on there. And the other problem we have here on this one here is our trace lines are missing. So like I said earlier, what I would do is just solder where needed a new connection basically. Instead of finding a thin piece of metal, we're not going to do that. We're gonna cheat. We're going to take, what I'm going to do is I'm just going to take a resistor, which I have plenty of, and what I'm going to do is solder it where it needs to be soldered. So I know this connection point right here leads over to this connection point there, which of course leads over to these others here. So I'm just going to solder this point to that point right there, and what that's going to do is complete that part of the circuit. And then I'll just end up snipping those tips off right there, so it's easier to work with if I just leave the whole resistor in place to begin with. So I'll just kind of bend it. You don't want to solder it in such a way that it makes connection to any other points, like its neighboring resistors and diodes and whatnot. So, okay, in this case here, looks like it's in a good spot. So I'm going to go ahead and heat my tip up. I already cleaned it. Quickly just heat that point up there first. And put a dab of my solder there. So now that point is on there. And same thing here. I'll just put a little bit on first. Hold it down to the point I want to weld it or solder it to. And I'll just quickly put another dab down there. So now that part of the circuit is completed. And what I'll do is I'll just take a pair of tweezers. And these are used to cut cuticles off your fingers and whatnot. So we're just going to push that down a little though. And then I just snip it off right here. Snip that point off there. And same thing here. I'll just go ahead and snip that extra tip that's hanging out off. There we go. So it's good, nice and firm on there, so it's not going to go nowhere. And the next area I see where there's a problem is where the board was burnt right here. Right along the area there. You can see the coating is, you know, burnt off. I believe the connection is still fine there. Matter of fact, I'll just go ahead and test it real quick with a multimeter here. And what I'm going to do is on the multimeter, I'm just going to put it on tone basically to test my continuity basically. And when I touch the two ends, if they're toning out, giving a beep, I know the connection is good. So I'm going to go ahead and do that. Set my multimeter where it needs to be. Okay, so it's where it needs to be, and I'm going to touch the tips together first to make sure it's going to do what I need. Okay, so that completes the circuit there. Alright, so I know that this part of the board here traces and goes over to here. So I know that board is good. That point of the board is good. It's not shorted out. I know the line I made over here is good, and it's good all the way to the other connection points. You want to make sure it's not shorted out by quickly just, you know, doing something like that. It's not affecting the board whatsoever by testing other points. The other point that's messed up is going to be from this point to this point. You can see the trace line is missing there. So that's the next point we want to trace over and make the same connection. So because this is still showing good, I'm not gonna go ahead and make a jump from there to there. It tells me the line is still fine. So I'm gonna do the same thing. Take another resistor. I'm just using resistors once again because I have an abundance of these guys and I hardly ever use them. So I'm gonna place my resistor there and just kind of wrap it around a little bit, and we'll snip off the tip again. Let's see. Matter of fact, I know my fingers are probably in the way of the video a lot, but I'm using my phone, so okay, so there we go. Once again, I'm gonna clean the tip of my solder gun off. I'm going to prep it again so it's good there. And I'm going to make the connection here, heat that up first, and it doesn't take long at all. I mean, a quick dab on it is good enough. You don't want to overheat your capacitor or any other components that you may be soldering on there, because then you can end up damaging them. They're really designed for a quick solder on and off, so that's why it's good to prep first. If you don't prep, it takes longer for the solder to grab on. So we're going to go ahead and prep that one. Okay, and that one sticks up a little, so I don't want it to stick up too much. So what I'm going to do is push it down. I'm just going to push it down a little, heat it up again, and just kind of push it closer to where I need it. Right there. blow on it real quick if you want, and it'll quickly set it. Sometimes if it gets too hot, it'll take a little bit longer. Otherwise, it sets pretty quick. Snip off the ends you don't need. You don't want them shorting out any other part of the board. You want the circuit to operate the way it's designed to operate. So essentially what we're doing here is we're redesigning the circuit to do what we need without having to replace this entire board. A lot of times in electronics, it's just like one or two things that goes bad. Usually about one thing that goes bad, and people spend a lot of money just to replace it. You don't need to replace it. Especially on circuit boards, they're usually dead giveaways, like the capacitor that on this one that clearly showed that it exploded. So it's a dead giveaway, and then flip it over and you see the trace lines are missing. So I'm going to tone this out. I know my connection point there is good, but my next connection problem I see is right here. At this point right here, because it burnt off the trace lines right where your capacitor goes through the hole, the capacitor really isn't completing the circuit over here. And it is, but it's not. It's going to fail because you can see it moving right here. It's cracked. It's cracked right there at the tip. And to prove it, what you do is you just kind of hold it there, and you'll hear it bouncing around the tone because it's shorted out right there. So once again, I see this connection point connects to here, it connects to there, it connects to over there, somewhere way over here. I can either quickly jump it and connect it there, or I can quickly jump it and connect it here. Whichever the shortest run, however you want to do it, is fine, as long as it's staying connected, because the circuit board from trace lines from here to here are good. But at this point right here, it's broken. It's barely touching. As a matter of fact, it's broken from this point almost all the way through to the other end right here, and it's just hanging on right there. That's not good. We want to make a better circuit, so we're going to do the same thing. A lot of talking, I know. Okay. So same thing. I'm just going to take another extra resistor, place it where I need it. And I'm just using these resistors because instead of grabbing extra wire, these are actually perfect. They're nice and firm. They're going to do what you need them to do without a big fuss with using other wiring of sorts. Okay, so about like that. That should be good. So when I go to solder that down, I want to make sure that it's not going to be touching on its neighbor right next to it. In fact, that one's acting kind of weird. I'll just grab this other one and just do that. Set it right there. And I have to pause it my video. Plug in my battery. My phone was about dead. Alright, so the camera on my phone went out, or the light on the camera on my phone went out. It got a little too hot. That Samsung 4 is designed to shut off. The backlight there when it overheats, and the phone actually itself will shut down too if it overheats, which is pretty cool. And it'll also stop charging itself. Anyhow, so I'm just going to solder this point on here, okay, and then jump it right over to that other point right there. There we go. So So now I know that part of the circuit is completed. Same thing. I'm going to snip it off where I don't need. And now I'm going to go ahead and just snip off these ends here. I don't need them no more. Kind of use them to make sure you cover your eyes, or if you're snipping them off. Okay, I'm going to check the continuity. I want to make sure it makes it to the other part of the circuit, which it isn't, so I got a problem here somewhere. Okay, there it is. It is. There it goes. Sometimes you gotta, with the flux that builds up on the outside, you gotta kind of press on it a little to get through the circuit. There we go. Okay, so that's good. It's not shorted out on the other part of the board. That's good. That's good. Okay, that's good. Now, I don't see any other problems on this particular board. So the only problem was that one capacitor, and I'm not going to bother covering this up with any sort of protective gels or coatings of plastic or whatnot that's out there on the market. You know, for the sole reason it has stances, you know, little pegs here that stand off of the frame that it's going to be on, so there's nothing that's going to touch or short out the back of here. If that was the case, all of these would be coated, or a sheet of plastic would have been, a hard piece of plastic would have been on the back part of here. So I'm going to flip it over here. This is the capacitor I replaced. The other one is fine. Every other point of the board looks good, so the only other thing to do is going to be plug it back into the AC unit, let it go into, let the heat pump do its job, and once the freeze sensor senses that it's getting a little too cold, it should send the signal over to the board here to kick on the heater inside the house, which will end up telling the unit on the outside to reverse, so the Freon in there will start defrosting the ice buildup on the outside. And that's it for this one. Hope you learned something.